In the previous video, we have seen what is random experiment and its corresponding sample spaces. In this lecture, we shall learn what is an event, union and intersection of two events, simple event, composite event, and finally mutually exclusive events. What is an event? Any subset of possible outcomes of a random experiment is called an event. And we know that the set of all possible outcomes of a random experiment is called the sample space. So, any subset of the sample space is known as an event. In this example, we are flipping a single coin and the corresponding sample space consists of two elements, that is head and tail. If E be the set that consists of only one element, that is head, then E is a subset of the sample space. That's why E is the event that a head appears when we flip a coin. In this example, we are flipping two coins at a time and S be the sample space. Now, if E be the set consists of two elements, that is head and head tail, then obviously E be the subset of S. Then E is the event that a head appears on the first coin when we flip the two coins. In this example, we are flipping two dice at a time and S be the sample space. Now, if E be the set, then E is a subset of S, then E is an event. What event is this? You see, if we add 6 and 1, we get 7. If we add 5 and 2, we get 7. Similarly, 4 and 3, we get 7. Like this. So, E is the event that the sum of the dice equals 7. What is the union of two events? For any two events, E and F, of a sample space S, we define the new event E union F to consist of all outcomes that are either in E or in F or in both E and F. The event E union F is called the union of the event E and the event F. If S consists of two elements, green and blue, then if E is equal to green and F is equal to blue, then E union F is equal to the set which consists of green and blue both. So that is the whole sample space actually. Now in this example where we are tossing two coins at a time, here you see S be the sample space and here E, if we take head and head tail. On the other hand, if we take F is equal to tail head and head, then if I take the union of E and F, we get the set which consists of head tail and tail head, because we have taken head already. So E union F is the event that at least one of the coins lands head. what is the intersection of two events? For any two events E and F, we may also define the new event EF. It's called the intersection of E and F to consist of all outcomes that are both in E and F. That is, the event EF, that is actually E intersection F, will occur only if both E and F occur. In this example, let S be the sample space. If E is equal to this set and F is equal to this set, if I take the intersection, that is EF, we get head, tail and tail head, that is both in E and F. So EF is the event that exactly one head and one tail occur. In this example, you see S be our sample space. If E be this set and F be this set, then the intersection EF does not contain any outcome and hence could not occur because there is no common element between them. So this type of event is referred as null event and denoted by phi. So here EF that equal to phi, the null set. Now what is simple event? An event E is called a simple event or an elementary event if E contains exactly one element. As for example, throwing an ordinary die. The sample space is 1, 2, 3, 4, 5, 6. If I take A equal to the even number and B be the set that consists of the numbers which are divided by 3 and C be the set which consists of only a single element 2. In this case, C is the simple event. Why is that? Because it consists of only one element. What is composite event? An event is called a composite event if that event contains more than one element. The composite event also known as compound event. In our previous example, here A and B contains more than one element. So in this example, A and B are compound or composite event. Mutually exclusive events. Two events connected to a given random experiment are said to be mutually exclusive events if these two events can never happen simultaneously in any performance of the random experiment. That means A intersection B is equal to null set. In this example, you see throwing an ordinary die, the sample space Bs. Let A be the event that consists of 2, 4, 6, that means it consists only the even numbers. B be the events that consist of 1, 3, 5, that means it consists only odd numbers. Then if I take the intersection, that is null set. As A and B can never occur simultaneously, so A or B are mutually exclusive events.